Hello, this is Venki Rao from IBM. Today, I want to share with you a simple web app that I designed to help businesses identify the best location for a new full-service restaurant. To make this easy to follow, I'm going to pick two possible locations from which to choose. Cambridge, Massachusetts, which is across the Charles River from Boston, and Wellesley, Massachusetts, which is a few miles west of Boston. Now, it's time to do some geospatial analytics. And we first start with calculating drive time distances to understand what sort of customers each of these locations is likely to attract. To do this, I choose a drive time of 15 minutes and I choose the normal traffic conditions for 6 p.m. on a Friday evening. Let's click the Run Analysis button. While this analysis is running, let's quickly recap what we have done so far. We wanted to identify the best location for our restaurant, so we started with two potential locations, Cambridge and Wellesley. We then decided to calculate the drive time distance to each of these locations based on traffic at 6 p.m. on Fridays, so we can understand the typical areas where our customers are likely to come from. Instead of using usual traffic patterns at a certain time, I could also have used live traffic, which is something all of us use every day when we use various mapping applications on our smartphone to get from point A to point B. Our analysis is now complete, and you can see this visually represented on our map. Next, let's get the demographics information from these two locations. To do this, we choose the variables with which to enrich our data. We pick income variables like average household income, average disposable income, population variables like the total population, the population annual growth rate, and some restaurant-related variables like sales, sales potential, and the leakage surplus factor. Let's click the Run Analysis button. While this analysis is running, let's understand why we picked the variables that we did. We wanted to understand both the demand and the supply side of the areas covered by the 15-minute drive time area. To understand demand, we chose the income and population variables, and to understand supply, we chose the restaurant-specific variables. A quick note on the leakage surplus variable that we selected. The indicator values range from -100 to +100, with a positive number indicating a leakage, a negative number indicating a surplus, and a large number indicating less competition. Now that our analysis is run, we can view the attribute table to see which of our two locations looks more promising. The first row relates to Wellesley, and the second row relates to Cambridge. We can see that Wellesley has higher income levels, and although the population in Cambridge is much greater than that of Wellesley, the population growth rates are about the same. When we look at the leakage surplus factor, that's where our decision turns squarely in Wellesley's favor. Wellesley has excess demand, while in Cambridge's case, supply outstrips demand by quite a margin. A final step in our analysis is to determine the list of block groups that our restaurant covers so that we can conduct a hyper-localized and targeted marketing campaign. So we choose our preferred location, which is Wellesley, and we leave out Cambridge from further consideration. And then we run an analysis on the FIPS to identify whom we should target in a direct marketing campaign. So let's go ahead and run this analysis. While this analysis is running, a quick note about FIPS. FIPS is the ID field of the block group layer. A census block group is a geographical unit used by the US Census Bureau. It is the smallest geographical unit for which the Bureau publishes sample data. Typically, block groups have a population of 600 to 3,000 people. By identifying block groups relevant to our location, we can run hyper-localized marketing campaigns to drive traffic to our location. Our analysis is now complete. When we view the attribute table, we can see a summary of all the census block groups where we should run our marketing campaign. So to recap, I designed this web app to help businesses choose the location for the next full-service restaurant. This app allows you to take into account traffic patterns as well as demand and supply variables to identify the ideal location for your next full-service restaurant. What's more, it helps provide a hyper-localized list of census blocks within which to target your marketing efforts using IBM's cutting-edge predictive analytics and marketing tools. That brings me to the end of this video. Thank you for watching and have a great day.